4.5 billion years ago. In the chaos of the early solar system, a cloud of gas and dust collapsed under its own gravity. At the center, our sun ignited into a newborn star. Around it, countless fragments of rock and metal collided, merging into larger bodies. One of these would become Earth. Its surface was a molten ocean of magma, constantly bombarded by asteroids. In this violent beginning, the foundations of continents, oceans, and eventually life itself were set in motion amid the cosmic storm. As Earth cooled, its crust began to harden, forming the planet's first primitive surface. Volcanoes erupted constantly, spewing gases into the atmosphere: carbon dioxide, methane, and water vapor. There was no oxygen, no life to breathe it. Gigantic impacts from space still struck, reshaping the planet's face. One colossal collision with a Mars-sized body formed the Moon. This new companion stabilized Earth's tilt, creating more predictable seasons. Beneath the toxic skies, oceans began to gather, and within them, hidden in darkness, the building blocks of life quietly assembled. By 4.0 billion years ago, Earth's surface was cool enough for rain to fall. Torrential storms lasted for millennia, filling the low basins to create the first oceans. Lightning flashed through thick clouds, striking the water and sparking complex chemical reactions. In a primordial soup of minerals and organic molecules, life may have first emerged. Primitive microbarrier-like forms appeared, possibly near hydrothermal vents on the ocean floor, where heat and minerals provided energy. These earliest life forms would become the ancestors of all future organisms. Around 3.8 billion years ago, life was microscopic and simple prokaryotic cells without nuclei. They thrived in oceans under a dim, hazy sky. Using chemical energy, they began to transform their environment in subtle ways. Some evolved photosynthesis, capturing sunlight to produce energy and releasing oxygen as waste. This oxygen didn't yet accumulate in the air. It was absorbed by iron in the oceans, forming massive bands of rusted rock. Over time, these ancient microbes would trigger one of the most profound environmental shifts in Earth's history. By 2.5 billion years ago, photosynthetic cyanobacteria had become widespread, producing oxygen at a global scale. Eventually, the ocean's iron supply was saturated, and oxygen began to build up in the atmosphere. This great oxidation event was both a blessing and a curse. For early anaerobic life, oxygen was toxic, causing a massive die-off. But it also enabled the evolution of more complex, energy-hungry cells. Earth's skies turned from orange to blue, and a protective ozone layer formed, shielding life from harmful ultraviolet radiation. Over hundreds of millions of years, life adapted to the oxygen-rich world. Eukaryotic cells, organisms with internal structures and nuclei appeared, possibly from a symbiotic merger between different microbes. These new cells were more versatile, able to develop into multicellular forms. In the oceans, colonies of algae and simple organisms began to thrive. Continental plates shifted, forming supercontinents like Nuna. Climate fluctuated between warm periods and intense ice ages, testing life's resilience. Through these cycles, Earth was slowly preparing for an explosion of biological diversity. Around 700 million years ago, Earth endured a snowball Earth phase. When glaciers may have covered much of the planet, life retreated to refuges near hydrothermal vents and equatorial oceans. Volcanic eruptions eventually released enough greenhouse gases to melt the ice. This dramatic warming flooded the oceans with nutrients, sparking a burst of evolution. By 600 million years ago, the first large, soft-bodied multicellular organisms appeared, strange alien forms that would lay the foundation for the Cambrian explosion to come. About 541 million years ago, the Cambrian explosion transformed life forever. In just tens of millions of years, most major animal groups evolved. Hard shells, exoskeletons, and complex body plans appeared. Trilobites, early arthropods, and strange predators roamed the seas. On land, bare rock awaited colonization. Oxygen levels rose, supporting larger, more active creatures. This evolutionary leap marked the beginning of a dynamic era of competition, adaptation, and mass extinctions that would shape the course of life for the next half-billion years. Life continued to diversify through the Ordovician period. Seas were rich with trilobites, brachiopods, and early fish with primitive jaws. Plants began their first tentative steps onto land, forming low mats along shorelines. Coral reefs started to take shape in shallow waters, but around 444 million years ago, a major ice age struck. Sea levels dropped drastically, destroying coastal habitats. This first great mass extinction wiped out nearly 85% of marine species, a stark reminder that survival on Earth has always been fragile. The Silurian period brought recovery. Warm, shallow seas returned, reefs flourished, and fish developed better jaws and fins. On land, plants evolved vascular systems, allowing them to grow taller and spread inland. Simple arthropods like scorpions and millipedes began to explore the shore. By the Devonian period, around 419 million years ago, the age of fishes had arrived. Oceans teemed with armored placoderms and early sharks, while lobe-finned fish developed limbs, paving the way for the first vertebrates to walk on land. The Devonian was also a time of greening continents. Forests of primitive trees took root, altering the atmosphere by increasing oxygen levels. Amphibians emerged, breathing air and living between water and land. Yet the Devonian ended in disaster. A series of extinctions, possibly triggered by climate shifts and oxygen depletion in oceans, struck marine ecosystems. Coral reefs collapsed, many fish lineages vanished. Life survived, but the survivors would shape the ecosystems of the next great chapter, the rise of giant swamp forests and reptiles. The Carboniferous period saw lush, swampy forests dominate the land, filled with giant ferns and horsetails. Insects grew to enormous sizes in the oxygen-rich air dragonflies, with wingspans over half a meter. Amphibians thrived in wetlands, but new reptiles evolved tough-shelled eggs, freeing them from the need to lay eggs in water. These reptiles would become the ancestors of future dinosaurs, birds, and mammals. Vast deposits of dead plant matter formed the coal beds we still mine today, storing ancient sunlight beneath the Earth's surface. By the Permian period, supercontinent Pangaea had formed, uniting most of Earth's land. Deserts spread across the interior, while early conifers adapted to drier climates. Reptiles diversified, producing early mammal-like forms known as synapsids. But the Permian ended with the most catastrophic mass extinction in Earth's history, the Great Dying. Around 252 million years ago, massive volcanic eruptions in Siberia released vast amounts of greenhouse gases, heating the planet, acidifying oceans, and wiping out 90% of all species. Life stood at the brink. From the ashes of the Permian extinction, the Triassic period began. Early dinosaurs appeared alongside small, agile mammal ancestors. Pangaea's vast deserts alternated with fertile coastal plains. Reptiles ruled the seas and skies, ichthyosaurs and pterosaurs evolved. But another extinction event at the end of the Triassic cleared the stage for dinosaurs to dominate. Over the next 135 million years, they would become the most successful large animals the world had ever seen, ruling every continent and evolving into an astonishing variety of forms. The Jurassic period was a golden age for dinosaurs. Massive sauropods like Brachiosaurus roamed lush plains, while predatory theropods hunted across forests. The first birds took to the skies, evolved from small, feathered dinosaurs. Oceans were home to giant marine reptiles, and coral reefs thrived. Conifers, cycads, and ginkgos dominated the plant world. Warm, stable climates allowed life to flourish. This was the age of giants. But even in this world of abundance, evolutionary arms races between predator and prey shaped the future of life. In the Cretaceous period, flowering plants appeared, transforming ecosystems. Their nectar attracted pollinators, bees, butterflies, and other insects, creating new food chains. Dinosaurs reached their peak diversity. Armored ankylosaurs, horned ceratopsians, swift raptors, and towering tyrannosaurs. Oceans hosted mosasaurs, plesiosaurs, and giant sharks. Mammals remained small, mostly nocturnal, awaiting their moment. That moment came abruptly 66 million years ago, when a massive asteroid struck near modern-day Yucatan. The impact unleashed global wildfires, blocked sunlight, and triggered a mass extinction that ended the reign of the dinosaurs. In the aftermath of the asteroid impact, Earth was a devastated world. Dust and soot blocked sunlight for months, plunging the planet into a nuclear winter. Plants withered, food chains collapsed, and three-quarters of all species vanished. Yet, some small creatures endured. Bird-surviving dinosaurs took to the skies. Mammals, once insignificant, began to diversify rapidly. With dinosaurs gone, empty ecological niches opened. Over millions of years, mammals grew larger, more adaptable, and better suited to exploit a wide variety of environments across the recovering planet. The Paleogene period saw Earth warming again. Forests spread from pole to pole, creating vast habitats for new life. Mammals flourished, hoofed grazers, predators, and primates emerged. Whales evolved from land-dwelling ancestors and returned to the sea. Birds filled the skies in incredible diversity. Insects, now tied to flowering plants, thrived in this green world. Tectonic plates continued to drift. Continents shifted toward their modern positions. With each passing epoch, ecosystems grew more complex, setting the stage for the rise of truly intelligent life. By the Neogene period, grasslands had expanded dramatically. Herds of grazing animals like horses, antelope, and early elephants roamed open plains. Predators evolved to hunt them: big cats, hyenas, and canines. Early hominins appeared in Africa, walking upright and using simple tools. The climate began to cool, leading toward the Ice Age. Mountain ranges rose higher, altering weather patterns. These changes forced animals, including our ancestors, to adapt or perish. It was in this shifting, challenging world that the seeds of humanity took root. 2 million years ago, the Pleistocene epoch began. Massive ice sheets advanced and retreated repeatedly, locking up vast amounts of water and lowering sea levels. Gigantic mammals, mammoths, mastodons, saber-toothed cats thrived in the cold. Early humans evolved larger brains, mastered fire, and developed more sophisticated tools. They hunted cooperatively, built shelters, and began to migrate out of Africa. This Ice Age world was harsh, but it forged the adaptability and resilience that would allow humans to eventually dominate the planet. Homo sapiens appeared roughly 300,000 years ago. With advanced language, abstract thought, and complex social structures, they spread across continents. By 50,000 years ago, humans created art, music, and ritual, expressing their growing cultural identity. They hunted efficiently, domesticated dogs, and learned to exploit diverse environments. In time, humans reached Australia, the Americas, and remote islands. Alongside their expansion, they altered ecosystems, sometimes driving large species to extinction. The balance of power on Earth had shifted irreversibly toward this single, remarkable species. The end of the last ice age around 12,000 years ago brought dramatic change. Glaciers retreated, seas rose, and climates stabilized. In fertile valleys, humans began to farm, domesticating plants and animals. Agriculture fueled permanent settlements, which grew into villages and then cities. Trade networks formed, knowledge spread, and civilizations rose in Mesopotamia, Egypt, the Indus Valley, and China. Written language emerged, allowing history to be recorded. Humanity had entered a new era, no longer just surviving, but actively shaping the planet's destiny. Bronze and Iron Ages brought metallurgy, advanced tools, and powerful empires. Kingdoms expanded through conquest and trade. Roads, ships, and money linked distant cultures. Science, philosophy, and art flourished in Greece, China, India, and the Islamic world. Populations grew, cities expanded, and human impact on the environment intensified. Forests were cleared, rivers dammed, and species hunted to extinction. While knowledge advanced, so did conflict. As societies competed for resources, humanity's reach now spanned much of the globe, for better and for worse. The Middle Ages and Renaissance reshaped the human world. New technologies, printing presses, navigational instruments, and improved ships accelerated exploration and communication. European voyages connected the old and new worlds, exchanging crops, animals, and ideas. The scientific revolution challenged ancient beliefs, unlocking the laws of physics, astronomy, and biology. Art and literature thrived, inspired by both classical heritage and new discoveries. Humanity's understanding of its place in the universe deepened, yet its exploitation of the planet's resources also grew ever more intense. The Industrial Revolution transformed society. Steam engines, mechanized factories, and railways accelerated production and transportation. Population surged as cities grew rapidly. Fossil fuels powered machines but filled the air with pollution. Scientific and medical advances improved health and longevity. New communication systems, telegraphs, telephones connected the world faster than ever before. Industry and technology brought prosperity to some, hardship to others, and unprecedented demands on Earth's resources. Humanity's ability to alter the planet had reached a new, more powerful scale. By the 20th century, technology advanced at breakneck speed. Automobiles, airplanes, and electricity transformed daily life. 2 world wars unleashed destruction on an unimaginable scale, but also drove innovation. The space age began, and humans set foot on the moon. Computers shrank from room-sized machines to personal devices, revolutionizing communication and knowledge sharing. Global populations soared past billions, and environmental concerns grew urgent. The power to change the planet for good or ill was now firmly in human hands, with consequences yet unknown. The late 20th and early 21st centuries brought the digital revolution. The internet connected billions, allowing instant access to information and global collaboration. Smartphones placed computing power in every pocket. Medical breakthroughs extended life expectancy, while genetic research unlocked the code of life itself. Yet climate change, habitat loss, and mass extinctions accelerated. Renewable energy and conservation efforts rose in response. Humanity stood at a crossroads capable of solving planetary crises, yet still driven by consumption and growth that strain Earth's systems. Today, satellites orbit above, mapping every inch of Earth. Scientists monitor melting glaciers, shifting weather patterns, and the health of ecosystems. Space probes explore distant planets, seeking to understand our place in the cosmos. At the same time, human culture thrives in countless forms: art, music, science, and technology interwoven. Our species now shapes the planet more than any natural force, for better and for worse. The choices we make in the coming decades will echo across millennia to come. Looking back, Earth's 4.5 billion-year story is one of transformation and resilience. From molten rock to blue planet, from microbes to civilizations, each chapter was shaped by chance and change. Catastrophes cleared the way for new beginnings, and life adapted time after time. The planet has survived impacts, ice ages, and mass extinctions. It has hosted empires and watched them fade. And still, the Earth turns, carrying its newest chapter, humanity, into an uncertain but hopeful future, shaped by knowledge and responsibility. Earth's deep history reminds us that change is the only constant. Continents drift, climates shift, and species rise and fall. Humanity is unique in its ability to understand this history and to foresee possible futures. Our survival will depend on respecting the delicate balance of Earth's systems. The same forces that shaped life for billions of years still operate today. We are part of a continuum stretching back to the planet's fiery birth, inheritors of an ancient, ongoing story. From the first raindrops that cooled a molten world to the sprawling cities of today, Earth's transformation is awe-inspiring. Each layer of rock holds a record of past worlds: shallow seas where mountains now stand, tropical forests beneath polar ice, deserts that once teemed with life. Studying these clues helps us prepare for the changes ahead. Just as life adapted through countless challenges, so too must humanity adapt now, guided by the lessons written into the very stones beneath our feet. The biosphere today is a tapestry woven from countless evolutionary threads. Coral reefs built over millennia, forests recycling air and water, grasslands supporting vast migrations, all are products of deep time. Yet this intricate balance is fragile. Extinction rates are now higher than at almost any point in the last 65 million years. Protecting these systems means honoring the ancient processes that created them. We are both caretakers and beneficiaries of Earth's immense natural heritage, entrusted with its future well-being. Technological power gives us the ability to heal as well as to harm. Renewable energy, ecosystem restoration, and sustainable farming can counteract damage done. Global cooperation could stabilize climate, protect biodiversity, and ensure resources for generations to come. But these efforts require foresight and unity, virtues not always easy for our species. The same ingenuity that carried us from stone tools to space exploration can also guide us toward a future where both humanity and the planet thrive together. Our planet's history also humbles us. For more than 99.9% of Earth's existence, humans were not here. Entire worlds of creatures lived, evolved, and disappeared long before our arrival. In this perspective, our civilizations are brief flashes of light against the backdrop of geologic time. Recognizing this truth can inspire humility and care in our actions. The choices we make in decades may shape the next thousands of years, influencing whether our story continues or fades into the rock record. The story of Earth is also the story of survival through catastrophe. From asteroid impacts to volcanic winters, from icebound epochs to runaway warming, life has persisted. Often, new beginnings arose from great loss. Understanding these cycles helps us see our current challenges in context. Though threats loom: climate change, resource depletion, environmental collapse, history shows that resilience is possible. Humanity's challenge is to channel that resilience consciously, avoiding self-inflicted disasters and nurturing the conditions that allow life to flourish. Looking outward, our exploration of other planets deepens appreciation for Earth. Mars holds evidence of ancient rivers. Venus hints at a past more temperate, yet neither sustains life today. Our planet's combination of water, atmosphere, and protective magnetic field is rare. Nowhere else, so far, offers such abundance. This uniqueness underscores the urgency of preservation. The vast cosmos may hold other life, but until we find it, Earth remains our only home, a jewel shaped by 4.5 billion years of cosmic artistry. The next chapters are unwritten. Will humanity enter an age of environmental harmony or descend into crises of our own making? Technology will advance, climates will shift, and cultures will evolve. Our descendants may look back at this moment as a turning point. The story of Earth is now intertwined with the story of us. Whether we act as stewards or squanderers will determine how future ages judge our place in the grand sweep of planetary history. As we contemplate Earth's deep past, we also confront our shared destiny. Borders and divisions fade when seen from space, replaced by a single, fragile sphere. This perspective invites cooperation across cultures and nations. Protecting the planet is not a task. For some, it is the responsibility of all. The legacy we leave will not only define our species, but will also shape the future of every living thing sharing this extraordinary, ancient world we call home. The journey from stardust to sentient life is the greatest story ever told. Earth's landscapes, life forms, and cultures are chapters in a vast cosmic epic. By understanding this history, we gain both wonder and responsibility. We stand at the threshold of choices that will echo into the far future. As the planet continues its eternal dance through space, may we honor its past, protect its present, and shape a future worthy of the 4.5 billion year story we have inherited. 4.5 billion years, condensed into 20 minutes, is only a glimpse of Earth's immense story. Yet even in this brief telling, we see the forces of creation, destruction, adaptation, and renewal that define our world. We are the latest expression of those forces, capable of imagining the entire sweep of time. The Earth will continue, with or without us, but our actions can ensure that life's story remains rich and beautiful. The next chapter is ours to write.